this is the experiment on specific heat capacity, and here is the virtually boiling water, and I'm gonna fill it in here. I got the metals in the freezer. I made marks in here to show me where exactly I have 50 milliliters. You cannot see that in the camera, and which of course is 50 grams. I'm measuring the temperature here just before I'm going to put the metal in here, and let's see, it's pretty much 90 degrees. So this is not a rounded 90, that's pretty much exactly, actually it's 91 degrees. So 91 degrees. Now I'm going to plunge the metal, piece of metal from the freezer in there, and it's going to be lead. So there we go. And then we're going to just let it sit here for a moment. And I'm going to take the other one as well. So my other example is going to be brass. And again, I'm going to measure temperature. I don't have the time to jot these down here. Everything needs to go relatively fast. So I want to say that's 89 degrees Celsius. Now let's make it, yeah, 89 degrees Celsius. Okay, now plunge the brass in there. And by the way, I checked the temperature earlier in the freezer. That was -7 degrees Celsius. And then I have to wait a little bit for the heat from the hot water to flow into the cold metals. That's why I'm not going to measure the mixing temperature right away. Let's see what I get here. Okay, of course it was from hot water, and hot water with a high specific heat capacity means also that compared to the lead or the brass means also that the temperature is relatively high, and at this point actually it seems like it's not really changing anymore. So I'm gonna, I consider this to have bottomed out. So this is 65 degrees Celsius for the lead, and then I'm gonna put this one in here for the brass. The brass has less density, therefore it also, for the same kind of block that I put in here, it has less mass, but it has a quite higher specific heat capacity, so it is able to absorb more heat from the hot water. So I expect the temperature to go down more, and in fact it does. And it kind of looks like this is where it has bottomed out, 54 degrees Celsius. Those are pretty much all the numbers that I need, with the exception of I still need the mass of the cubes, but I'm going to measure those on the side. You don't need to, you know how to measure the mass of something, and those are my example data. Thanks.